So our first one is we have state the theorem that justifies the statement. If a parallelogram, or if ABC is a parallelogram, then side AB is congruent to side CD, and side AC is congruent to side BC. So that's saying that this side is congruent to this side, and this side is congruent to this side. Yesterday's properties. Which property tells you that? So does anybody have their notes from yesterday? No, what'd you say, hon? It's property 1. What does that one say?
It's opposite sides are congruent.
Opposite sides are congruent. E is a parallelogram. Then we see that AD bisects BC. Of yesterday's properties, which one do we have that tells us that? Number 4. And what does number 4 tell you?
It's diagonals bisect each other.
Diagonals bisect each other. Okay, we have number 3. If ABC is a parallelogram, then angle A is congruent to angle D, and angle B is congruent to angle C.
Number 2 is opposite angles are congruent.
Opposite angles are congruent. That's number 2.
Yeah.
It's number 2 of the properties. And then we have that if ABC is a parallelogram, then angle A plus angle B's measures equal 180, and angle B plus angle D's measures equal 180. Which property is that? 3. And that is?
If consecutive angles are supplementary.
It's consecutive angles are sup. Thank you, ma'am. To show that a quadrilateral is a parallelogram. So our first way is from the direct definition. You show that both pairs of opposite sides of the quadrilateral are parallel. So parallelogram, opposite sides. So it has 2 sets of parallel sides that are opposite of each other. The next one is by a theorem. The theorem is to show that both pairs of opposite sides of the quadrilateral are congruent. You can do it by the theorem that both pairs of opposite angles of the quadrilateral are congruent. So once again, our first one was by definition, show that both pairs of opposite sides of the quadrilateral are parallel. The next one's by a theorem, show that both pairs of opposite sides of quadrilateral are congruent. The third one is by the theorem of showing that both pairs of opposite angles are congruent. Then we have by the theorem of showing that one angle of the quadrilateral is supplementary to both the consecutive angles. And then the third, or I guess it's the fourth one, is show that the diagonals of the quadrilateral bisect each other. Tell whether the quadrilateral is a parallelogram and explain why. So for our first example, is it a parallelogram? Yes, it is. And how did we know that? Yep. Jasmine's got this. What'd you say? Is the 8 supposed to be on the other side?
Yeah.
Yeah, each side, it goes with each part of that diagonal. So it goes, there's an 8 here and an 8 here. It's not drawn to scale. Okay, so back to question 1. Jasmine has the correct answer. Yes, it is. And we know that because opposite sides are congruent. So, yes, both pairs of opposite sides are congruent. Okay, our question number 2. We want to know if this is a parallelogram. So our first step is we want to see if the angles are related. We look across and we see that the angles 72 and 75 are not congruent. But to verify this, we can add 105 plus 75. And what do we get? We get 180, which is one of the rules, right? The consecutive angles are supplementary. So 105 plus 75 equals 180. But is 105 plus 72 180? Does not equal 180. So no, this is not a parallelogram. Consecutive angles are not sup. On question number 3, we see here, what do you notice? Is it a parallelogram?
Yes.
So number 3, we notice yes it is, and how did you know it?
They are across from each other. They all have the same. I don't know.
Opposite angles?
Yeah.
Angles are congruent. I should probably say both pairs of opposite angles. I'm going to add it up here. So both pairs of opposite angles are congruent. Our question number 3, or 4, we're on 4. Is number 4 a quadrilateral? I hear it. It's going to be yes, right? And we know this because we see that our diagonals bisect each other. Diagonals bisect each other. And you can see that here because when they cut each other in half, you have 5 on each side, so it divided it in half. 8s are divided in half, so we bisected both of those. So when you look at number 5, is number 5 a parallelogram?
Yes. No.
So what we do is we look at which one deals with diagonals.
Yes.
And then we see what about our diagonals, Manchu? They are not congruent. So you see that your diagonals are not congruent. So no, diagonals are not bisected. Our next one is we want to see if this figure is a parallelogram. You have a couple options, but the easiest one is probably for us to see if these angles are supplementary. So if you add 98 and 82, I already hear Manchu telling us the answer. Does that equal 180? It does. And if we pick the other 98 and we add it to 82, we see again it's 180. So yes, it is a parallelogram because the consecutive angles are supplementary. Okay, our number 7, we want to see if this is a parallelogram. Is it a parallelogram?
No. Yes.
Do you have 2 pairs of parallel sides? So, remember parallel sides are the 2 sides that go on forever and they'll never touch. If we extended this out, are these going to stay where they don't intersect?
Yes. No. They don't go into the corner.
Dalen, I'm using your tools.
Yeah.
Oh boy.
So, are they going to intersect?
Yes.
Yeah, they're going to eventually intersect. So we see that our opposite sides aren't parallel. We can talk about the angles. Are opposite angles congruent? Nope. So no, not a parallelogram. Opposite angles are not congruent. And number 8, is this one going to be a parallelogram?
No.
No, Manchu is going to be correct. Manchu, how did you know that? What'd you say? Oh, okay, Janelle is correct. Janelle, how did you know that? So, no, opposite angles are not congruent. You could also say that consecutive angles are not supplementary because 120 plus 55 is 175. So that's not going to work either. So for number 9, you see that you have what? We have 2 right angles. Right? Can we say that that is a parallelogram? So we can see that angle, well, let's label them so I can talk about it easier. So if I label this A, B, C, D, we know that B and C are right angles, and we know that if you add 90 plus 90, it's 180, which means it's supplementary. But do we know anything about A and D? There's no marks there. We know nothing about them. So we cannot say that angle B is supplementary to angle A or angle C is supplementary to angle D. So we say there's not enough info. Not enough info. Don't know about angle A. Let's try that again. Angle A and angle D. Over here, we see that number 10, is it a quadrilateral and is it a parallelogram?
Yes.
Yes, and how did you know that?
Because the sides are congruent.
Yep, opposite sides are congruent. Both pairs of opposite sides are congruent. I'll just. Okay. We have our next 2. For number 11, is it, imagine again that diagonal, I did not fix it, is going through the vertices here. So please act like that's going across here. So, is that a parallelogram?
Yes.
Yes, it is. How did you know?
The opposite side of the group.
So in that one, we don't have sides. What do we have?
Angles,
What do we have?
lines,
What do we call the lines on the inside?
linear
Connected.
lines.
They are linear lines. A little redundant, but yes. What do we call these? They're what? They're being bisected. We call them the diagonals are being bisected. So yes, the diagonals are bisected. And last but not least is number 12 a parallelogram. No, and how did you know that? Because this one, the diagonals, right, aren't bisected. You have one diagonal that is, one portion of your diagonal is 6, and the other portion of your diagonal is 4. So when it's being cut, it's not being cut evenly. So we say no. No diagonals are not bisected. Do not bisect each other.